many rural areas, access to clean water remains a daily challenge. Without a reliable water supply, villagers struggle to get enough water for essential needs like drinking, cooking, and hygiene. Many are forced to rely on untreated sources, putting their health at risk. Safe and accessible water is crucial for their well-being and quality of life. In Malaysia, many regions still lack proper access to clean water. Urban areas may have better supply, but rural areas continue to struggle. This chart shows the reality. While urban areas have high water availability, rural communities are left behind. Even when water is available, contamination is a major concern. Bacteria, pesticides, and heavy metals threaten public health. Unsafe water affects overall health. Contaminated water can lead to diseases, weakening communities, and endangering lives. The solution must be affordable, sustainable, and accessible to everyone. The source of river water is polluted by agricultural waste and daily activities. These contaminants enter the rivers, putting millions of lives at risk. Every drop of polluted water flows into homes, leading to cholera, harming aquatic life, and even causing severe health issues like body aches. So, what's the solution? A simple, low-cost, and sustainable water purification system. We introduce a 3-stage water purification system designed for rural Malaysia. A solution that is not only effective, but also easy to implement and maintain. This system takes inspiration from nature and simple scientific principles to deliver safe, clean drinking water to communities in need. Stage 1. Wetland-based pre-filtration. Stage 2. Biochar filtration. Stage 3. Solar disinfection, aka SODIS. And finally, water is stored for daily consumption. The first stage is a constructed wetland, a natural filter that removes sediments, heavy metals, and bacteria. These wetlands mimic the Earth's natural filtration process, allowing water to pass through layers of plants and gravel that trap harmful particles and impurities. In the root bed media, this layer is made up of clay. It prevents deep waste infiltration and prevents substance filtered to diffuse into the soil. In this layer, gravel was used as substrate to enhance the microbial breakdown processes. Bioremediation and denitrification processes also occur here. In the common reed grass layer, the root reduces water speed and aids filtration. It gives better conditions for sedimentation of suspended solids. Wetlands remove up to 80% of contaminants, making the water cleaner before moving to the next stage. Unlike expensive filtration systems, wetlands require little maintenance, and their effectiveness improves over time as microbial communities develop. This is a truly sustainable way to clean water. Our water sources are increasingly threatened by pollution. But there's a sustainable solution: biochar. This powerful filtration system is built layer by layer. It starts with biochar, then we add a layer of coconut husk. Next comes a layer of gravel, and finally, a layer of sand to complete the filtration process. Biochar's unique structure traps heavy metals, pesticides, and organic pollutants, effectively cleaning water at a molecular level. It works by adsorption, binding these harmful substances and removing them from the water. Biochar helps to adsorb heavy metal and pollutants. It's sustainable and cost-effective, and works to enhance water purification. For the next stage, we will use SODIS treatment. SODIS stands for Solar Disinfection. Why SODIS? Well, SODIS requires no electricity, no chemicals, and no expensive filtration systems, making it cheaper than most water purification methods. All it needs is sunlight and a clear plastic or glass container, making it an ideal solution for communities with limited resources. So, moving on to its implementation, the biochar filtered water flows into a large transparent tank. To enhance UV exposure, the bottom of the tank will be lined with a reflective material, ensuring that the sun's UV rays are distributed evenly throughout the water for more effective disinfection. The sun emits ultraviolet UV radiation, specifically, which penetrates the water and directly damages the DNA and RNA of bacteria, viruses, and protozoa. This prevents them from reproducing, effectively neutralizing their ability to cause infections. Furthermore, the heat generated by sunlight raises the water temperature, accelerating the destruction of harmful microorganisms. At temperatures above 50 dU4C, many bacteria and viruses break down more quickly, making the disinfection process even more effective. Additionally, sunlight triggers the formation of reactive oxygen species, such as hydroxyl radicals and hydrogen peroxide, which chemically attack and destroy microbial cell structures. These combined effects of UV radiation, heat exposure, and ROS production make SODIS a powerful and natural method for purifying water. To keep the water clean, it should be stored in sealed, food-grade tanks made of HDPE, stainless steel, or fiberglass to prevent contamination and bacterial growth. Airtight lids keep out dust and insects, while a dedicated outlet tap prevents cross-contamination. For communities, 5,000 to 10,000 litre tanks can supply multiple households and store enough purified water to supply multiple households. Tanks should be rinsed and disinfected every 3 to 6 months to ensure continued water safety. Ensuring access to clean and safe drinking water is important for protecting public health and improving quality of life, especially in communities that lack proper water treatment. While this system offers an effective solution, its success depends not just on the purification process, but also on proper care and maintenance to keep it working well over time. To make sure the system stays effective, each part of the process needs regular upkeep. The wetland-based filtration system should be checked often to prevent blockages and make sure it continues removing dirt and pollutants properly. The biochar filter must be cleaned and replaced when needed to keep it working efficiently. The SODIS process relies on sunlight, so tanks and containers should be kept clean to allow the sun's rays to pass through. Once purified, the water should be stored in sealed, food-safe tanks with airtight lids and proper taps to prevent contamination. Regular cleaning of storage tanks and filters is essential to keep the water safe. Teaching communities how to properly maintain the system will help ensure long-term success. To make clean water more available, a simple and efficient distribution system should be set up to get purified water to those who need it. Gravity-fed systems are a cost-effective way to deliver water without needing electricity or pumps. By using this water purification system, communities can reduce diseases, improve health, and create a more sustainable future. With the right support, education, and community involvement, this solution can provide safe drinking water for years to come, improving lives in the process. And so, that is all from us. Thank you for watching.